Hello guys, today I'll show you how to control a standard RGB LED and then I'll show you how to generate many colors with a single RGB LED. So let's get started. Now see this LED, it has 4 pins and this one is common cathode LED. And in this video we will discuss only about this. Okay, now see the pin diagram of it. This longest one is the cathode, this pin is for red, this one is for green and the last one for blue. This LED is a combination of 3 LEDs, red LED, green LED and the blue LED. Let's see its basic circuit diagram. If we consider R, G, B like this, then there will be 3 terminals like this. So these are the 3 LEDs in it, and from this taken one cathode pin, and this cathode is common for all the 3 LEDs. So this is what it looks like. This one is R, then the longest one is the cathode, and rest of the 2 is green and blue. And before going to programming, we have to see some basic thing. So these are the 3 basic color, red, green and blue. If we mix green and blue, then we will get the cyan color. Okay, and if we mix red and blue, then we will get magenta, and if we mix green and red, then we will get yellow, and if we mix all 3 colors, that is red, green and blue, then we will get white. Now let's see this thing on the breadboard. Put the RGB LED. I have put the cathode pin here. So I am connecting the cathode in the first place to the ground, and I am connecting a 470 ohm resistor with red pin, 1.5 kilo ohm resistor with green pin, and another 1.5 kilo ohm resistor with blue pin. Because in this type of LED, the color green and blue glows more brighter than red. So to maintain the equal intensity of light, I have connected more resistor than this red pin. Okay. Now red wire to the red pin, blue to the blue pin, and green wire to the green pin. And I am connecting all these 3 to positive rail. Now I am applying 5 volt to this. See, it is glowing white. If I remove these 2, now it is blue. I think you are looking it less blue and more white. So I am keeping one cover like this. Now in the camera it perfectly blue. Now I am applying the red pin to the positive rail. See, it is red, green means green. Now from here, if we apply red and green, then we should get yellow. So red and green. See, it is yellow here. Green and blue, it is cyan, this color. Now if I apply blue and red, then it should be magenta. Okay, so in this way we are getting 7 basic color with this LED. Okay, so after knowing all this basic thing, now let's come to the programming. I'm connecting the cathode pin to ground pin of Arduino, blue pin to the pin number 6, red pin to the pin number 3, and green pin to the pin number 5. The reason I am connecting pin 3, 5 and 6, because these 3 pins are PWM pin, and with this PWM pin we can generate 16 million color from this type of LED. How it is possible to generate 16 million color from this type of LED? So the explanation is, the PWM signal is in 8-bit. 8-bit PWM signal means it is 2 to the power 8, and 2 to the power 8 equal to 256. So from 0 to 255 we have total of 256 steps. As we know, the output voltage of any Arduino pin having 5 volt, so we can divide the 5 volt by 256 steps. Now see, RGB LED having 3 pins. For now just consider it as 3 options, and we have 256 steps. Now if we apply permutation on this, we can write it as NPR. Here N equal to 256, R equal to 3. As we know, NPR is equal to factorial n divided by n minus r factorial. So here it is 256 factorial, and below this 256 minus 3, that means we have 253 factorial. Okay, now we can write it as 253 factorial multiplied by 254 multiplied by 255 multiplied by 256, and below it is 253. 253 factorial got cancelled out. Now if we do the multiplication of 254, 255, 256, then we are getting it as 16,581,120. So we can say this type of LED can generate 16 million color. So it is approximately 16 million. It is more than 16 million, but we generally say it is 16 million. Now if you do not want this calculation, here we have 256, then do permutation and r equal to 3 and equal to, see, we are getting this thing only. Now let's come to the programming. Now see this. As I have discussed in the previous video that we have to declare all the pin numbers as global variable. So I am writing here int and then red pin, and it is connected to pin number 3. Green pin is connected to pin number 5, and the blue pin is connected to pin number 6. Okay, and we will consider another variable, the delay time. So int and delay, as I am writing here d time, and I am considering as 500 millisecond. Okay, now as all the pins are output, so we have to declare all this. Red pin is output, then copy this and paste it 2 more time, and then copy the green pin, copy the blue pin. Okay, so this is all about our word setup. Then come to loop. First I will show you how to glow all the 7 color one by one, and then I will show you other colors. Okay, so for only basic color you need to write digital write, then make this red pin high and make a delay here d time. Okay, and after delay of 500 millisecond, just make it low, then without any delay make the green pin high, then make a delay here about d time, that is 500 millisecond. Okay, now after 500 millisecond make it low, and without any delay just make blue pin high. Here is our blue pin, and then after 500 millisecond of delay make this blue pin low. Okay, and make a delay here about 1 second. Okay, so let's see this very basic color, then we will move to other colors. So it is red green blue, red green blue. Okay, if you make a delay here about 1.5 second, then you will see it better. Okay, now move to other color, just remove this delay, and now copy this red pin, then copy the green pin, and the blue. Okay, and make a delay about D time. Now see, as I have told you in the beginning of the video, if you mix green and red color, then you will get yellow. Okay, so I'll write here yellow as a comment, and I'm making it low. Okay, we do not need blue color here. After this, I want the cyan color. To get cyan color, I need two colors, green and blue. So I am making the red pin low and blue pin high, and in this way we will get cyan color. We need one delay here, and then now we need magenta color. So to get magenta, we need red and blue, blue high, this green low. Okay, after delay of D time, I need white color. So to get white, I have to make all three high. Okay, and just write it as comment for our convenience, and it is red, blue, so it will be magenta. Okay, here is our 7 colors, and then make all the 3 pin low. It is important. Now making these 3 low means you are turning off your LED. So after turning off your LED, we want a delay of 1.5 second, and here I am writing 1 second. So after 1 second, each color will change, and then after 1.5 second, it will then again repeat all this. Okay, now upload this. Green, blue, yellow, cyan, magenta, white. Turning off for 1.5 seconds, then again it is repeating all the way. So this is how you will get all the 7 colors. Now see, but if you want other color than this, you cannot write here digital write, because it just turning on and turning off the LED, but it cannot control the brightness of particular LED. For that we need to write here analog write. Okay, now I'll show you this. Just remove all this. Now I am writing here analog write. Remove this. Okay, now this is analog write, and after this we have to choose a number between 0 to 255. 0 means completely 0 in the brightness, and 255 means full brightness. Okay, now I'm writing here 255, and see. Okay, now it is in full brightness. Now if I write here like 5, then see its brightness. Now see its brightness. In this way we can mixing up this brightness of all 3, and we will get other color also. So if I need orange color, then I need only 2 color, red and green, but difference in the brightness. Here I am writing 150, and in the red it is 255. 150 means you can say I am reducing it more, like 128. Now see here, 255 means in full brightness of red LED, and 128 means it's just half of its brightness. Okay, now I'm uploading this. See, it is not yellow, it is actually orange. Now if I reduce it more, like 30, then see its color. You can see it is not fully red. Okay, now if I add the blue color also, and its brightness like 100, then see the color. See, it is other than the 7 basic color. So by combining all these three, you can get 16 million colors. So by changing this number, you can get 16 million color, as we have 3 places here, and per place we have 256 option. And I have just explained mathematically how we are getting 16 million color. Okay, now see other thing here. To write this way, it is very lengthy. So there is other easy way to write this thing. We need one more function here, void, and then give your name, anything you want. I'm giving this function name is my color, and then I have to write, these are all integer number. Okay, that is why I have written here int, and then I am writing R here. You can write anything here. For R pin, I am writing here R, and then again int G, int blue. Okay, and after this, open the bracket, close it. In between this, we have to write something. Just write here analog write, and then write here red pin, comma, then R. So whatever you have written here, you have to write it here. Like this, we have to write it 2 more time. Here you have to write green pin, blue pin. Okay, here G, here blue. Okay, this is what you have to write here. Now see, after this, you do not need to write analog write here again. So now remove all this, and then now see here, you have to write here your function name, my color, I have written, then open and close bracket, then semicolon. Okay, now in the bracket you have to write the brightness of the LED. Let's say you want the cyan color, then we need to keep the red pin totally 0, then green in high brightness, blue in the high brightness. Okay, in this way you will get cyan color. Before we have written 3 lines for this, but now you can do it only with single line. Now if you want another color, then just copy this. Now I am making it as a comment, so it will not work. Now if you want another color, maybe it's white, so 255, 255, 255, it will be, the output color will be white. See, this is white. Okay, now I am making a delay here. Now upload this. Now it will be cyan white, cyan white after 1 second. So it is very easy way to write many color like this. Now after this, I think you can write your own color. In the internet there is a RGB color code. For all the color you can get the code. Okay, for that just go to Google, write like RGB code for See, there are more options here, like orange. So there are some numbers here. This 255 means for red, this 140 for green, and 0 for blue. So if you want dark orange, then just write 255 140 0. 255 140 and 0. Remove this. Okay, now see, you are getting this color. Now again, if you want some other color like purple, see the RGB code is given here. Like purple means 128 128, green is 0 here, so I am writing here 128, green 0 and 128. Upload this. See, you are getting this. If you want orchid color, then see, just copy this, it will be better way. Now upload this. Now I think you understood this. Now how to write in a faster way, just see this. First make all 0, then copy this. Okay, first we'll see for 3 colors, for red, then green, after that blue, then I want red and blue, means magenta, red and green means yellow, green and blue means cyan, then here it is white, then write any number, then write any random number like 20, 100, 255, then it is 200, 100, 10, then it is 255. I am creating some random colors like this. As your wish, you can do it. Okay, so this is all about. Now upload this and we'll see this. I think 1 second is very slow, so I am making it 300 millisecond for all. So guys, this is all for today. I hope you like this video. If so, then please like, share and subscribe to my channel. And if you have any doubt on this, then please let me know in the comment section. In the next video, I'll show you another topic on Arduino. Till then, stay happy and I will see you in the next video.